I want to introduce my the Three Stooges. I apologize. I get really goofy when I present, so my apologies and regrets. I'm Dimitri Glazkov. I've worked on WebKit and Blink for a very long time. Then I did web components, and now I'm kind of doing Blink again. And and this is Chris Harrelson, and he works on Slimming Paint.
I work on Slimming Paint. I've been on the Chrome team only for about 9 or 10 months, but I've already worked with some of you. And before that, I worked for quite a long time on Google Maps, and I was a big part of the new desktop maps website that you can use today. So that was part of my learning phase of learning to love the web and want to join Blink.
Hi, I'm Jochen. Hi, I work on Chrome and Blink and V8 and WebKit. Yeah, welcome.
We do not have. Oh, we do have. Awesome. Awesome. Welcome to the BlinkOn conference. This is where we celebrate our community and, you know, look at all of us and go, oh my God, look at this. Look around yourself. This is a big crowd, right? Everybody here in one way or the other feels passionate about the web, hopefully more in one way than the other. And hopes to contribute to the web. And by the way, here's a really nice breakdown over there of presentation of people representing different companies, which I think is kind of interesting. Yeah, Google is, there's a bunch of us here, but also there's a pretty healthy numbers of other contributors. So I just want to emphasize that this is not just a Google thing. And, you know, it's really important to us to make sure that there's voices who bring reason and stability to the company and to the team, the Blink team.
Okay, like the last two BlinkOns, we want to start out with looking back to what happened since BlinkOn 2. And again, let's start at looking at the size of the code base, and we still managed to add code at roughly the same rate as we remove code, which is very healthy and great. But it's not the case that we just don't work on the code base. Yeah, which would be one way to achieve this goal. But no, there's a healthy number of commits. So we just looked at Git short log, and there's roughly more than 50 commits per day. There's almost 500 unique contributors working on the code base in the last half year, which is like more than we had last time. It's great. So we're growing a number of contributors. We have a healthy number of commits, and still the code base remains small and manageable.
Sure that winters are good for Blink, right?
Yeah. Looking at the intent since BlinkOn 2, so there's more intent to do something since the last time. So we're more active than ever. Again, more than half of the intents are from non-Googlers, which is a great thing. Yeah. So I guess the process is kind of working, and yeah.
152 intents. Can you guys believe that? I'm sorry, I'm going to That's pretty cool, right? I don't need a microphone. I'm loud. How many did we ship?
Next slide. So we shipped quite a lot of stuff. It's by no way meant to be an exhaustive list, because it's just too much work to compile the list. But it just gives you a feeling or an idea of how much new stuff we put into the platform. There's big things like Shadow DOM. There's lots of smaller things, new APIs, new features, great stuff. And at the same time, we unshipped a lot of stuff again, some prefixed things which we managed to unprefix.
Right.
We removed unused features. Is this actually working? Yeah. Better? Yeah, slightly. One thing I want to highlight is show model dialog. It's finally behind the flag or not enabled by default. And again, it's not an exhaustive list. It's just some highlights. Also, the last time we looked back at the prediction from BlinkOn 1. So let's look back at like our goals from BlinkOn 2 and see what we did. So I just copied this from the slides from last time. The good news is like all our near-term goals either made a lot of progress, like oil pan or Blink scheduling, or actually shipped, right? Except for APIs and rendering, we couldn't remember what this is about.
Not awesome enough, clearly.
So if you look at merging with Chromium, it might not, like, what does progress here mean? Lots of progress happened by making the Chromium waterfall actually faster and more open, reduce the cycle time, make the try bots in a commit queue faster, which are all preconditions to be able to merge with Chromium, right? So Juice, I don't know, like if everybody knows what the project is about. It's about saving battery. There's progress. It's a lot of integration with the scheduler. We have perf bots that look at power consumption, right? So looking at the medium-term goals, naturally there's more stuff which is not yet shipped, but there's progress. GPU acceleration, we shipped it on Android. Remote frame is going to be important for all of you because we'll start moving iframes out of process, which means that your code has to be able to work with remote frames, like frames that are not actually hosted in the process. Bunch of other work. Binding split, which will hopefully enable us to reduce the link times and compile times a lot. GN, the new build tool.
How many of you guys know what GN is? So those of you who don't, go look for GN on Chromium Dev. It's amazing. It's the new replacement
Generate
for Ninja.
Ninja, right?
More than that, maybe. It's a build system that's really cool.
It's a meta build system on top of another better build system. Oh. There were also some speculative goals. We talked about trying JIT style resolution similar to what WebKit did, and we actually implemented it, and it turned out that on the benchmarks we cared about, it didn't really help a lot, so we aborted the project. I don't know about incremental style result, like anybody? No.
You can shout.
Yeah. There's been some investigation into it. The most concrete progress is that we're able to do more incremental and background parsing of HTML, in particular when you get it back from a XHR or in an iframe.
Cool. So I guess progress. Great. BlinkOn.js, there will also be a session. The framework is already, it's now about using it, which is like moving XSLT out of Blink, for example. So that's what happened since last time. On a high level, what are the results for our work?
Yes. Yeah, but you're basically like, we're doing all these amazing things. How do they translate into anything in real world? And I think a really good example would be a Topeka demo that the Polymer team has built. It generated quite a bit of really good positive impressions. It's a web that does not discriminate, a web app that does not discriminate between mobile and desktop. And it is incredibly smooth and really responsive and looks real nice too, which is a bonus. Most of this simply would not have been possible without the work that we've done over the last 6 months even. And there was all the work that went into web components and enabling performance and making sure that we don't fall off the wagon when we try to animate things and all this stuff. It's a tangible result. It's not necessarily tangible, but it's something you can see and say, hey, I did this. This is the progress we made. And here comes the most important part. Past is great. We can look at it and revel in our awesomeness, right? But what do we do next? And I think if you look at the things that we do next, we still come back to that fairly informative slide that we presented at the last BlinkOn as well. And that is, why are people not using web platform? And if you look at this diagram, it's very clear that there's 3 large chunks of stoppers that are there. Number 1 is performance. We knew that one. Capabilities. We sort of knew that one too. And productivity, which is something we knew as well. And I think it's really interesting that the Vision Media folks broke it down into multiple things. But if you look at these as symptoms rather than the actual cause, you will see that the problem is that the web platform is very wide. It has some extremely opinionated bits, some really not opinionated bits. And there's simply no one way that makes sense to do things. And hence all these different developers beating themselves and trying to figure out how to make their app work. And all the hacks and all the frameworks that we see are just symptoms of that pain. So the basic principle is, why don't we just fix that, right? Let's just remove the 3 top stoppers. And performance, where we have multiple projects working on that.
Slimming paint. Woo! Scheduler. Service worker, push notifications, web components, dev tools, ECMAScript 6, lots of stuff.
Yeah, and if you look at this, we seem to be doing all the right things, and all we need to make sure is that these are exactly the right things, because there's only so many of us, even though there's a lot of us, right? A large number of people. There's only so many things we can do at once. At the same time, as we try to remove these 3 top stoppers, there's different ways we can approach this, right? We could say, hey, developers, guess what? We recognize the web platform is difficult for you to do this. Why don't we just build a whole different platform for you that you can use? That would be awesome, right? So no, instead, we need to recognize that there's some strengths of the web platform that are fairly significant, and they're really what makes up the web. This is somewhat random list, but it spells access, which which is almost like success in the true web platform fashion. So not only we can't spell, we don't really have all the letters yet. But anyway, if you look at this, you go universal. We are the only platform. A web platform is the only platform that's available on every device. Yes, yes. If you don't have a web browser, what kind of platform are you? We are composable, and that's one of the amazing things that enabled all those mashups. The ability to take a thing from somewhere else and smash it into your app is something that is like very actually difficult to do in other platforms. We are semantic, which plays to 2 things. One is that you can look at the markup HTML, and you can reason about what is inside of the app without running the app. And the other thing is that you can now look at the app and determine its states, and you can capture those states as this magical thing we call URLs. And so you can hopefully go to your app, you look at the URL, bookmark it, and come back to it later, and it'll be the same thing. Or at least that's what we hope it would be. And this is super important for like a really strong feature of the web platform. And ephemeral is also important, right? There's a XKCD slide that people have shown at the previous BlinkOn, where we basically say, you know, installing apps is nice, but can't you just go to the app via URL? And again, we can do that. We actually can. Wow. And safe, of course, is the last but not least. Is we finally figured out origin-based security, and it seems to work well. And we just need to keep doing that and not break that. That seems important.
So another thing, if you look at the transition we did from desktop to mobile, and you take a step back, and at the lessons learned there, what did we do wrong, what went well, you kind of can derive a number of long-term strategies or patterns which we should try to follow. An important thing is to keep the platform open. Again, it's not supposed to be like a Chrome-only future, but we want to have a web platform future. It means that we need to work with standards. We need to make sure that other browser implementers can actually follow along. We learned that layering is important, that if you add a lot of high-level APIs, you will have a hard time porting this over to the next cool thing. I mean, we came from desktop to mobile. I don't know what will come after mobile, but definitely there will be something after mobile. If you look at a glass or a watch, it's just not a phone. It's a different platform. Who knows what will come next? And we will need to be able to port our platform to whatever comes next. So we fare far better if we have primitives that you can build up higher level APIs on top of it, instead of just having a bunch of very high level APIs. It's important to stay healthy. We mentioned this at the beginning, like the code base not exploding. There's a lot of ongoing refactoring work or work to make APIs nice. And this is important work that enables us to react to new trends faster. Ship often and iterate. It's also a mantra here at Google. Don't try to make the first version perfect. Make it good enough to build and iterate on it. And then be data-driven. What does this mean? Data can mean benchmarks. It doesn't mean you just run the existing benchmarks. We also have to take a step back and look at the benchmarks. Is this really the stuff we care for optimizing?
And the stats, right? The usage stats, for example, is a good example.
And also, it doesn't, like you mentioned usage stats. We know that enterprises, for example, don't report usage stats to us. So it's also important to look at the data and know what the biases of the data you have, where you base your decisions on. But in general, you shouldn't just be like, oh, I know that this is best. So instead, you should look for data to drive your decision. And so if you look at the last 3 slides, you can take those principles like access or the ways to stay healthy I just mentioned. And these are 3 different dimensions that span a state space, essentially. And we did this exercise yesterday, or I was told that we did because I was on the plane. And it's actually possible to take all the projects we're currently working on and describe them in terms of how they are located in the state space. Like, are they improving healthiness? Are they adding capabilities? You know, are they universal, more or less? And so this is a nice way to look at, like, what are we working on? What does it mean to be a web platform feature? But on the other hand, since you can describe any project that is like a web platform project in terms of these 3 dimensions, we need to define some kind of focus, like what is our priority?
One second. One thing I want to mention is that you actually can have extra dimensional projects, and that would be a really strong signal if we look at that, these 3 dimensions that we just described, that this is not a web platform project. And so, but you're right. The coordinate space is great. It gives you this ability to reason about how, you know, where does it fit into general web platform, you know, progress arena. But we need to have a shape defined, you know, like inside of that coordinate space, and say, this is what we're focusing on today. This is what we want to do today. This is the most important area to succeed in today, because you can go really wide and cover every bit of it, and then you'll run out of people very quickly. And so what we want to do at this BlinkOn, and this is like super important, so there's a very convenient feature that was provided to you, and that is the lack of the power supplies. So your laptops will stop working at some point. Unfortunately, sorry. This is where you really need to start focusing and thinking, this is important. This is the key thing. Like all of that other stuff is nice. This is a key thing for this group of people. This is what we want to do. We want to focus our efforts into a very specific goal, and that goal is right there. It's enabled in bold developers to easily maintain and make and maintain, again in bold, products that offer a modern user experience.
Hello? Okay. I'd also like to, at BlinkOn 2, we had a stated goal of focusing on mobile first in our efforts. And we did a pretty good job since then to focus on the things that are most important for mobile performance, as well as capability. So you might ask, what is the difference between this and the previous goal? And I think this is just an evolution in thinking, where we think this goal actually, the actions you would take to implement this, as we're describing it here and in subsequent slides, are wholly consistent with focusing on mobile, because we want to be able to enable the permissions that developers are demanding the most. We want to be able to fix the worst performance problems. But the way this is stated is we think more direct and logical and actionable in terms of helping to know precisely what it is that you made better. And so we're going to go in the next slides through some examples.
So like a really good question is modern user experience. Be specific, tell me what that means. And we thought really long and hard about this, and we came up with a very simple 4-guideline, 4-rule system that you can reason about at any point, and you can apply to any app in the world. And again, this is really important, so pay attention. We also applied some criteria to those 4 rules, and these criteria may change, that's okay. But right now, these are the things that we care about. So number 1 is loading. When you first navigate to your app, we give you 100 or 1 second effectively to load. You probably need to be presenting something. It's probably not okay to not paint anything at all during that time, but it's okay not to react to user input for 1 second. It's okay. This is our allowance. This is like your thing, like, I'm budgeting because I'm an ephemeral app. This is my budget. So 1 second. Next is whenever the user starts to interact with the UI, Jacob Nielsen actually is the one who came up with the 100 milliseconds, is this shortest unnoticeable reaction time. We want to give you 100 milliseconds to react. And you better start changing your UI state 100 milliseconds. The pixels on the screen better start changing 100 milliseconds after you you started interacting with the UI. Finger down is a really good stand-in right now, but it's not necessarily finger, it's anything. So it could be your cursor or whatever. Again, we want to make sure this is general and specific at the same time. What does this mean? This means basically that our input needs to be solid, and we need to be able to react to that input and stop anything we were doing at that time. And when we start transitioning from one UI state to another state, this needs to be done at 60 frames per second. So today, this means effectively 6 milliseconds chunks. We can make them larger, but that's effectively how much work you can do while transitioning. And we need to be able to make sure that the developers can accomplish this. And finally, when your UI is in acquiescent state, when nothing is happening UI-wise on the thing, This is the time for your app to catch up, to do sync, to do all the wonderful things that it couldn't do in time when it was reacting or loading or any of this stuff. And that work needs to be able to, again, stop as soon as the next UI interaction begins, which implies very strongly that all the work needs to be broken down into effectively 50 millisecond chunks. Because today it takes about 50 milliseconds for a user input event to propagate from the glass to the pixels on the screen. And so that's what we're aiming for. That's what we want to make sure. We want to make sure that whoever builds their app tomorrow, not tomorrow, but soon, can hit this 100% of the time. Yes. And from there, we can now extract and derive Blink priorities. So first thing is enable. There's bukus of web developers who want to build for the web platform and simply cannot do this because there's no capabilities that are crucial for their user engagement that are available on the web. Push notification is like top one right now, from what I heard. And there's a small list of those, short list of those things. And our top priority is to make sure that those things are available to the user so that the user can do the same thing they can do, or whatever is today's important thing. We need to be able to get them to the table. This is primarily about getting the user to the table. Literally, not literally, figuratively. Crap. If you don't have those things, nobody will come play with you.
And user, of course, means web developer. Right?
Web developer, yes. And talk about modern URI. Yeah.
So modern UX, as we just outlined, we define UX as a lot of performance-driven metrics, right? So UX, modern UX means that you are reactive, that you do the transitions, the animations within a certain time budget, and so it's important to make sure that we actually have a valid, broad road where you can enable the web developer to hit this modern UX, right? So it's not the goal to have like a very thin path, and if you hit exactly this path, you will get the 60 frames per second and the reactiveness which you want. But the goal is to kind of build an autobahn. So any web developer with a moderate amount of effort or small amount of effort can actually build a web app that provides this modern UX as we just defined.
Right. And performance and consistency are actually twin sisters, because in modern UX, consistent UI, consistent performance is super important. You can peak at 60 frames per second and then jank for like, a few frames, and it's like, yay, I'm doing 60 frames. Well, you're doing 59s effective, and that's like worse than 20. So
just one quick point. If you think about how performance applies to that previous slide where we have the 1 second and then 6 milliseconds and then 50 milliseconds, what that means is that once the app is loaded, the browser is not allowed to do anything that's anywhere close to exceeding those thresholds during those actions. And so everything that we do today that takes longer than 50 milliseconds, no matter what it is, like parsing a large chunk of data that comes off the network, if that takes more than 50 milliseconds, it's not acceptable. So we either need to, and data can be arbitrarily large, right? So you can never guarantee that parsing data will be less than 50 milliseconds. So there is a certain degree of new things that we need to put in place in order to do things incrementally or in the background or asynchronously, so that the browser can do stuff for you in smaller chunks and then come back to you. So it's not just make the pipes faster and replace this with that. It's some amount of larger things.
One thing that's also there that's implied is predictable performance, and that is also super important. And that goes into next slide, and that is easy to build and maintain. This is just as crucial, because no matter how cool and shiny our stuff is and how much we think we can hit 60 frames per second and how proud we are ourselves about that. If a developer cannot do this on the majority case, we haven't done anything.
And so if you think about whatever feature you're working on in terms of how will the developer benefit from this, this is an important question, but the question should actually ask, how will this enable a web developer to do what, right? And the what should be this modern UX we just described, right? So it's not just, you should not just think about the work you're doing and how does this enable a web developer to do something with the web, but this something should be very specific. It should be this modern UX. So this is what we want to focus on.
Right, and pretty much everything is derivative from there. You can look and say, but you didn't talk about battery consumption. Well, guess what? It's also important because that's all part of the performance. It's all tied into it. If you use up your battery and your app lasts for 10 seconds, you haven't done modern UX really. The other thing is, where does predictable fit in? It's really about productivity, because predictability only occurs, or it becomes a problem when you have complexity. And complexity is something developers create a lot. Web developers. We create complexity in C++ code too, but web developers. And so making sure that all of our primitives are tuned to work better in terms of predictability is super important. Let me give you very specific examples. How long will it take to run my custom element callbacks? We have no clue, right? Because it depends on the size of the tree. It may be 16 milliseconds, maybe 3, it could be 95. We have no clue. But guess what? You ain't gonna do nothing until you finish running those callbacks. We fall on our face. So these are the things we need to start thinking about and start reasoning about and saying, look, we are giving the main thread back to developers, and that's the challenges we face, and that's how we need to reorganize our thinking. These are the things we want to solve.
And you can also, there are some aspects of ergonomics that are things that help you more easily build a larger app. And you can ask, like, how does that apply to being in service of UX? So to some degree, it is directly in service because you need to be able to compose things in order to reason about a large application and actually know that it's going to perform. But secondly, modern UX is, you have to get something and sustain it for an innovation to be useful and for an app to be useful. And so just like health is an important strategy for Blink so that we can stay relevant and be able to ship features and have fewer bugs over the long term, this exact same thing applies to apps. And we need to make sure that apps are able to encapsulate their functionality of widgets effectively and so on, so that they can achieve the same goals.
So to recap, we presented you a state space, a three-dimensional state space. It has our strengths with our access. It has capabilities, performance, productivity, PPP. It has our long-term plans for health, and a web platform project can be described, is what we propose can be described in these 3 dimensions. We also gave you a goal, and the goal is to enable to easily build and maintain a modern UX. We tried to define what does it mean, a modern UX, and give you lots of examples. And this goal should be used to prioritize or to decide in this 3-dimensional state space what are the projects we should be working on. So take this from the talk, think about what you're working on in these 3 dimensions. Make sure that your project or the way you work on your project is well aligned with this goal we gave you, which is to enable to build and maintain a modern UX.
And our goal is simply to make sure that everything we do fits into the space we defined, fits into the shape that we defined in that space. And the shape is defined by that goal that we just talked about. You can slide back to it.
Dimitri is going to give a pop quiz later today Any? Okay, never mind.
No. Pop quiz. See.
Okay, so this was the forward-looking talk. I hope you remember it. BlinkOn 4 will be in spring 2015, somewhere Tokyo, Sydney. It's not yet planned. We will make sure that the date is fixed well.
What do you guys think, Tokyo or Sydney?
So
clearly, you're not going to be ones deciding. Sorry.
So whoever just answered volunteered for organizing it. Yeah, we will make sure that the location and date is fixed well in advance so people can book flights and hotels. BlinkOn 5 in fall 2015. I'm just guessing it's Mountain View.
Yes.
Yes. Thank you for listening to us.
Yay.
Are there any questions? Are we out of time? One, yeah. Again, so most things and projects we mentioned have scheduled sessions. If there's stuff which is missing, please make use of the breakout rooms we have. Yeah, questions? Ken.
Ken is asking what I learned from my work on the Maps project that made me want to work on Blink in order to fix those things. Performance, and then performance again, and it was across the board. I mean, some of it was WebGL, which you know extremely well. Some of it is like the search box when you it has a new kind of interaction with the search box where it does something like the Chrome Omnibox below and inside the page. And somehow implementing that was like way harder than it seemed like it should be, because we had this notion of a card and then the cards would move around and then fade in and out. And you're like, well, that should be easy, right? Like, it's just...
He's talking about productivity now.
It's just, you know, can't you just transform and opacity those cards or something? Yeah, we hit a bunch of things, you know. Some of it was about this issue that came up earlier of if the majority of developers can't figure out the fast path, then it's not useful. And these days, it's easier to hit the fast path than it was when we built the product, but it's still not easy enough. Other things are we had to sort of reinvent our own version of what Web Components is, because Web Components was not available. So we have our own templating system that it's a Google templating system that we extended, but we used it in a very new way where we were doing client-side template processing, similar to what kind of some of the ones available today do, React and so on. It's very similar to that. So it's cool, but we had to spend a lot of time making it fast and dealing with the fact that if you have these client-side templates, you have to sort of encode it in JavaScript strings and then parse those strings, and then it bloats your JavaScript, and then you have to parse the JavaScript, and compiling the JavaScript takes a long time, and it's hard to control it. That was actually reducing that time. Actually, was the like firefighting we had to do the most just before we launched, just because there's just so much of it, and it's so easy for it to get big. And splitting it up into pieces, you have to roll your own systems, so on and so forth. So
if you look at the modern frameworks and what people are doing today, the capabilities inside the system are sort of there. So the frameworks become this humongous coordination systems. And coordinating when things should happen and how is like a large problem for developers.
Yeah. Another thing that's an interesting anecdote is when I came to Blink, one of the first things I tried to work on, and I did work on some, was style recalc. And I'm like, oh, that should be easy, right? Like, I don't know, you just apply the style to the thing and then it updates your div. And then all the time must be spent in drawing pixels or something. And I just looked at the code, I'm like, wow, there's so much going on in there. And then I thought, that can't be, you have to be able to get rid of all that. And then, oh wait, you can't get rid of it. Oh, okay. So that indicates that there's also a combination of two things. One is that I think even professional, trying really hard, excellent programmer web developers don't understand and have a strong enough intuition about why things might be expensive in the system we have because of the declarative aspects of it for the most part. So I think there's one aspect which is just explaining things, like literally, you know, here's a Khan Academy video on why style recalc takes as long as it does. And I actually wrote such a doc that hopefully we'll make public at some point soon. And you know, I showed it to people and they're like, wow, I learned something about this. And the other half is just, it shouldn't be this hard. It should be more obvious somehow about how to make it fast.
And the curve of the delta T of complexity or predictability is like wild today, because, you know, yes, you've managed to make this work, and then you pray for a long time that when you add another piece of code, it still will do the same thing and will not suddenly become n squared or, you know, blow out your budget on frames somewhere else.
Any other questions? Do you? Okay, yeah, go ahead. In one of the slides, there was a 6 millisecond duration of time to process a frame at 60 frames per second. And as we know, 1,000 divided by 60 is 16, not 6. So you're wondering where the 6 came from.
Right. It's basically today's goal for for providing space for developers to do work on within 60 milliseconds of the frame, because we basically say we'll probably eat 10 milliseconds doing our composite-y and painty and style calcy things. Here's 6 milliseconds we give to you. So just as an illustration, this time is actually less. We are not hitting this consistently on like a device like Nexus 5, for example.
So the 6 milliseconds is developer time, not so-called inherent time to draw a frame. Yeah, of course. Yeah.
I have a follow-up question on that. Can you elaborate more on the 50 millisecond time taken after that 6 milliseconds?
Okay, this thing turns off quick. The question is, could you elaborate more on the 50 millisecond time and where that came from?
So that's basically our. Do you want to respond? Okay.
So the idea is that once you don't have a running animation or an ongoing user input, you have some slack to do idle work, like garbage collection, for example, or some cleanup work. But at the same time, you need to stay alert for maybe the next finger down event is coming. And so if you look at the time budget we have for the finger down event, which is 100 milliseconds, and essentially the 50 milliseconds are kind of, this is supposed to make sure that no matter what work you're doing, you still return early enough to the main thread that in case there's a pending input event, you still somehow manage to hit the time budget you have to react to the input event.
This 50 milliseconds, it directly correlates to finger down, because you might be doing some cleanup work, but when you finger down, you should be able to stop. How do you stop? Well, you have to chunk your work, or other strategies. But right now, stop your work, and to stop your work, you have to chunk.
So you can't be like, oh, now I'm idle. I know I'm idle because I got just the finger up event. So with a high likelihood, there's some milliseconds. I'll just go off 1 second and clean up the world. Instead, you have to chunk it up in less than 100 milliseconds, far less than 100 milliseconds chunks to be able to still guarantee reactiveness when the next input event comes. More questions?
Sure. What are you most excited about doing?
What are you the most excited doing in the next 6 months?
What is the most exciting thing that you see coming?
The most exciting thing that I see coming in the next 6 months. For me, I am so excited about the things we can do with productivity and ergonomics to guide developers to that path. Like, I want to go talk to DevTools people and say, we want to encode these things into DevTools so that, like, every time you've wasted more than 1 second loading stuff, we're going to do like draw a big red dragon somewhere or something like this. And every time your input event handling took more than 100 milliseconds and you blew your budget, you know, you crash. I don't know. I'm something like this, you know. Anyway, this is what excites me the most, is like, how do we take and look at this thing and come up with ergonomics and primitives for developers to guide them toward the path? And I think everybody has answers, right? No?
I'm really excited about what's coming up with V8, actually. We're implementing now a lot of the new features in the next versions of ECMAScript, classes, sets, maps, all those things. And also, I think we're about to make really big strides in performance, especially on asm.js style performance, which is really exciting to me. One thing I didn't mention about, again, coming back to my experience with maps, is reliable JavaScript performance of a program that runs a lot of code is actually very, very tricky the way things are right now. So I'm excited about that.
I stole your question.
I'm also excited about V8. What I think is great. We saw the app, which we also demoed at the Google I/O, that showed the results the last time. And on top of that, we now got the service worker, which, like, even compared to Android, a really compelling offline story. There's lots of device APIs in the pipeline. We have APIs like Navigator Connect, so there's lots of stuff in the pipeline or about to be released or is released, actually, that brings us on par or even further along the line than mobile native apps. And so I'm really excited to see developers picking up those new capabilities and APIs and building apps on top of it.
As you can see, we're really excited.
Okay. Yeah. Then thank you for listening to us.
We hit the time thing. See, we're within budget. So.
Great. Thanks, guys.